All right, that water sound disappeared.
Yes.
Well, hello, everybody. I'm speaking from southern sunny California foothills. We're just getting into starting our summer, just about to begin our main honey flow, which may or may not occur due to lack of soil moisture. So I've been asked to speak on this presentation of reading the combs. And let's see, there we go. So one of the things, let me ask you a question, Jeannie. Do you have very many beginners listening tonight?
Well, we trained about 40 people last year and 15 this year. I don't know how many. I don't know that there are many of them here tonight. That is an issue.
Okay.
But
So anyway, for the beginners, a warning. You're going to get a ton of conflicting advice on beekeeping. When I searched for beekeeping on Google, you get 32 million results come up. So there's no way in the world you're going to listen to everybody's opinion. And the problem that we have relates to the Dunning-Kruger curve, where people don't recognize their own incompetence. So you typically start with your first hive, and the first year of beekeeping is usually pretty easy. They make some honey, and at this point, you're at the peak of inflated self-assessment. And this is when people start blogging and get really strong opinions and think everybody else is an idiot, that they're the smartest beekeeper that ever existed. And then Varroa tends to catch up and they lose all their hives and they may hit the trough of disillusionment. Some people give up beekeeping. Someday there's going to be this monster yard sale from all the hives and extractors that have been bought by the hobbyist beekeepers these last few years. I don't know what's going to happen to them all. But many will get back on the horse. And then you get on this slope of experience and enlightenment and slowly attaining mastery of the craft, which is going to take you years and years and years. Even those of us who have been at it for over 50 years, we are still on the learning curve. You're never going to figure everything out. You're going to have more, the longer you keep bees, the more questions you are going to have about beekeeping. So realize this, be careful who you get your advice from. So if you want to get your advice from the bees, these are the rules of beekeeping from the bees' point of view. Number one, they need a warm, dry cavity. When the honeybee, Western honeybee, evolved out of Africa up to the temperate areas, it needed to maintain that subtropical conditions from where it evolved. And it does that by moving into cavities in hollow trees or in rocks where it can keep these subtropical conditions during cold weather. They're the only insect that maintains elevated body temperatures during the winter. From a practical perspective, all you need is any kind of box. The bees don't care whether it's a Langstroth hive or a Wari hive or deep supers or medium supers or top bar. That's up to the preference of the beekeeper. The bees are fine with any warm, dry box. The second thing they need is food. And the two natural foods for honeybees are nectar and pollen coming from flowers. From a practical perspective, if there is rainy weather or a dearth, or you want to stimulate the bees, you can feed them sugar syrup as a substitute for nectar, or pollen substitute, that's a substitute for pollen. Other than that, just be aware they need food. And then number three, they need to manage their parasites. Every species has parasites, and the honeybee has a new one. Invaded the US in right around 1990, the Varroa mite that you see right here. And the Varroa mite is a problematic parasite on its own, but the main thing it does is it transmits viruses, notably deformed wing virus. And the bees are in this evolutionary process of learning how to deal with the Varroa mite. And right now they need a lot of help. So if the beekeeper can step in and help them manage their parasites, you'll be much more successful with beekeeping. And that's the end of the rules. The bees don't care about anything else. They need a cavity, they need food, and they need to manage their parasites. So my recipe for healthy hives, in general, you keep young, vigorous queens. A queen, typically, if she's laying a lot of eggs during the season, she's good for about 18 months of egg laying, and then she'll start to run out of sperm, and her workers will supersede her and replace her. So on average, the queens live for about 1.5 years if there's a long enough season for a lot of brood rearing. If you're out in California, it's a little bit over 1 year to 1.5 years. So requeening your colonies is one way of keeping them vigorous and healthy. Provide good nutrition either by putting the bees somewhere where there's a lot of natural forage, or moving them to better forage when there's a dearth, or possibly supplemental feeding, although supplemental feeding is not necessarily called for at all unless you have a specific reason to do that. Controlling varroa, not just from time to time, but all year long. That will help the colonies be much more productive. Then minimize the toxins in the hive. If you start dumping things like essential oils in your hive or a lot of synthetic miticides or have agricultural toxins, that can be problematic for the bees. Out here in California, we have a couple of toxic plants which can wipe out a hive, natural toxins. So minimize the toxin level in the hive. And the main thing for success is to be proactive rather than reactive. Rather than waiting for a colony to occur, foresee it coming and be proactive to prevent the problem. So my suggestions to you is, number one, realize, yes, bees are fascinating animals, but they're just animals. And keeping them alive and healthy is just basic animal husbandry, the same as keeping any other sort of livestock. Number two, your best bet is copy a consistently successful local beekeeper. Now, successful doesn't mean he's the guy or she's the person in the newspapers or the club president or making videos. Success, the easiest way to tell a successful beekeeper is that their main problem every spring is they have too many bees and they need to get rid of bees. So anybody who's going out and buying replacement bees in the springtime is not the person that you want to be getting advice from, because they obviously haven't yet figured out how to be a successful beekeeper. Understand the 4 horsemen of the apocalypse. Cold weather puts bee colonies under stress. Poor nutrition, massive problem for bees, especially out here where we have these long dearths out in the West. Toxins, of course, and then the parasites. Any kind of bee problem can be narrowed down to generally one of these 4 different horsemen of bee apocalypse. My suggestion number 4 is make all your management decisions based upon the biological needs of the colony, rather than what you read in the book or what somebody tells you to do. Get your information from the colony itself. And you do that by learning how to read the combs. So that's what this presentation is going to go about, how to look at the combs and let the bees tell you what they need. This is written very nicely way back in 1920 by Tickner Edwards in this book. And I always liked this line right here. He says, "And so the best bee master is always the one who most exactly obeys the orders from the hive." So you can do all kinds of things to the hive and you can screw it up or maybe help them, but following the orders of the hive makes you the best bee master. So I am a servant to my bees, just making life better for them. It helps to understand the business model or the ecological niche of the honeybee superorganism. And understand it's a highly efficient competitor for floral resources, which occur sporadically. It has 2 objections, and be aware of these objectives. One, it wants to store enough food in the form of honey reserves to make it through dearths. And 2, when times are good, it wants to reproduce, and it reproduces by sending out drones or by swarming. These are the 2 most important things to a honeybee colony: to store honey and to try to reproduce. And you're not going to be able to fight either of those. Just understand this is always going to be the 2 objectives of the honeybee colony. In order to manage those objectives, it's a jump on all the other pollinators and its competitors by using those honey stores to maintain this standing army of foragers, always at the ready to take advantage of any kind of floral resources out there. And that army conserves energy. It just sits tight and doesn't move until the scout bees say it's time to go out there. So first thing in the morning, the field force doesn't leave until the scouts go out, say, yeah, there's nectar still here, or there's pollen over here, and they come back and communicate that, and then the wave of the foragers go out. The key thing is they don't waste any unnecessary energy. All of the bees in the hive are always aware of the overall food supply and how full the cavity they're living in is as far as its capacity. And they all share food, and they all thrive or starve equally. If a colony starves, they all starve at the same time. And every worker in the hive is considered to be expendable except for the queen, who they will always be the last bee alive in the hive during starvation event. Now, the queen does function as the ovary and the pheromonal center of the colony, but she has very little other influence. She does not call the shots or tell anybody in the colony what to do. It's the nurse bees, the young bees, the bees that are less than 2 weeks old, that run the show, and they control everything because they control the food supply of the colony. They're the only bees in the hive that consume pollen coming back from the foragers and convert it into jelly, which they then share mouth to mouth with the queen, with all the other workers, and to our feeding the brood. So since they supply this currency of protein in the hive, they run the show. So it's all about the nurses. Understand the cues that the nurses use, that they see. They're aware of how much honey reserves there are in the hive, whether there's nectar coming in, whether there's pollen coming in, and also any pheromones from the queen, from the forager bees, and from the larvae. And the colony development follows nectar and pollen availability, not calendar dates. Hang on, I thought I put a new slide in here. So your seasons, they're not based at all. Oops, what did I just do? See, the seasonal buildup and decline of the colony is not based upon day length or dates. It's based upon nectar and pollen supply. So for each season, you'll notice that the colony population, this is being the pollen and nectar supply, lags slightly behind the pollen and nectar supply. And what they try to do is to build up to maximum strength right for the main honey flow, so they store as much honey as possible. So the 4 phases they go through are build up, and then when they're about half to 2/3 full strength, they will try to reproduce with drones and swarming. Then they go into the food storage mode during the main honey flow, and then they will go quickly reduce the population of the hive during the dearth period, and they go back into survival mode, which may occur during the winter in your area, or if you're in Southern California, it occurs during the late summer. So this dearth period, or this the winter for bees in Southern California, runs from July until November, and then the spring starts in November and then proceeds to what you guys would call winter. So it has nothing to do with day length, and has nothing to do with the calendar days. It has to do with the availability of nectar and pollen. And you can actually get 2 peaks a year in some areas if you have an early flow and then a late flow. The bees will go into survival mode between those dates. 2 other terms you should be aware of are attrition and recruitment. And attrition is the loss of workers due to them aging. They only live about 35 days during the spring and summer. The weather, wind, rain, they can die out there, predation or disease. And the key thing to understand is that a bee, as it gets old or as it gets sick, will do everything it can to avoid dying within the hive itself. They will use their last energy to do what's called altruistic self-removal and fly out of the hive and die elsewhere. So it's very unusual to find any dead bees within the hive unless they're trapped there by cold weather or due to starvation. Sometimes also a pesticide kill. So bees dying in the hive are unusual. The opposite of the attrition is the recruitment, or the rearing of young workers. And this is the main way that a colony deals with any kind of losses of bees, is it just simply ramps up production and rears a whole bunch of new replacement bees. And you can see the change in colony population. So this is the average daily gain or loss in number of bees in the colony. So you start off with a small colony. When they get into full buildup mode, you're gaining about 500 to 600 bees per day. Now, if the queen is laying 1,500 eggs a day, which she typically is doing this time of year, and you're gaining 500 bees a day, that means you're having about 1,000 bees a day dying from natural attrition. So understand this is huge turnover of bees throughout this buildup mode, until finally they reach equilibrium at about 40 times the queen's egg laying rate. And then you reach a top out where the attrition rate gets into equilibrium with the recruitment rate, and then the colony ceases to grow. So a queen that lays more eggs per day allows for a larger colony to develop. To lay 1,000 eggs a day, which is a moderate queen, colony won't get above 40,000 bees. But queens laying 1,500 eggs a day, then they get up to pushing that 6,000 bee level. And then later in the season, where attrition exceeds recruitment, it will slowly drop off in number of bees per day. And the colony age structure also changes over the year. And I made this colorful graph from some data from Lloyd Harris collected back in the 70s. Excuse me, my salivary glands have still not recovered from my radiation treatment, so I need to sip water frequently. And we'll get through this. This is color-coded. What the top of the line of all the colors is the total colony population anytime. This is from Manitoba, Canada. And then color-coded, these are the bees, the workers that are 0 to 12 days old. These are 13 to 24 days old, 24 to 36 days old, and very few bees get past 60 days during the summer. And then during the winter, we get much, much older bees. So we'll return to this at all times. And the dotted line is the total amount of brood within the hive at any time. And as you see, the total amount of brood can exceed the total amount of adult workers during the springtime. And the colony goes through a number of phases through the season. You don't have to read all these. I have a whole series on my website called Understanding Colony Buildup and Decline with about 13 articles that cover all of these phases. We're going to blast through them very quickly in this presentation. So if you want more information, it's all on my website, details on each one of these phases. The other suggestion I make, and before Varroa, it was very easy. I would say, if you don't understand what you're doing and don't know why you're opening a hive, just leave the bees alone. They'll be much better off without you. The only change is with Varroa, no, you need to get in there typically 2 to 3 times a year, maybe in our area, 4 times a year, to do something to control Varroa. Otherwise, it will kill the hive. Other than that, you should never take the lid off the hive unless you know exactly what you're going to be looking for and what you're going to do if you find it. Every beekeeper group can benefit by making a graph like this, showing what your main blooms are. This is one I made for our local club years ago by tracking the dates of the bloom. And we know that after fruit bloom, after the apples bloom, there's going to be a dearth period for about 2 weeks. We know about when swarming is going to happen. It typically takes about 60 to 90 days from when the colony starts brood rearing until they reach swarming, and then others 30 to 60 days before the main honey flow. Put in whenever the swarm season is, whenever any toxic pollens, like we have buckeye out here, which is toxic, and then when the dearth is there, and then when your fall bloom is here. So then you can take the dates off here, and anybody, like where I live, we have a lot of elevation change. So somebody who lives a mile away from me, they may, well, somebody who lives 5 miles away from me, their season may be a full month off from what my season is. So instead of going by the date, just go by what the phenology is, the plant bloom is. So this would help everybody to plan their beekeeping year. And the way you do it is you work backwards from each date, from your main honey flow, from swarming season, and then you can write down what you need to be doing at that time. So right now we're going to avoid starvation here. You're going to maybe, to maintain the buildup, if it rains, you may have to feed syrup or protein to the hive to maintain the buildup if you have a rainy spring. Get on Varroa early, be proactive, make sure that they don't, before you put your honey supers on, that you got Varroa taken care of. And then you understand that European foul brood may be a problem during the spring. And then swarm prevention, as that colony grows, that's going to be your main thing, so they don't swarm off and leave you with a small hive when the honey flow starts. No sense trying to draw comb at any other time of the year than when the honey flow is on. They're not going to draw comb when early, and they're not going to draw comb late. And then getting ready for winter, last chance to clean up on Varroa. So this is a very simple management plan you can make for any area, again, based upon the plant blooms. Okay, so now let's talk about looking inside the hive. What you're going to look for. Understand what the bee bread is, what fresh pollen is. So first, the foragers bring pollen in all throughout the brood nest, and the nurse bees consume it that day. They like the fresh pollen the best. If there's a surplus, more than they can eat, they'll leave it around the edges. Now you'll say, oh, look at that, they put it in a pollen band. No, they put it, the foragers store it everywhere. It just gets eaten in the middle. If there's a surplus left, you'll see this band around there, and the bees will ferment it into bee bread, and you can see the different color right here. The nurses always prefer fresh pollen to the older bee bread. Then here's sealed brood. The other word for sealed brood is varroa food. Is that a question? No, okay. It's varroa food. So if they're raising brood, they're rearing varroa. And then the open brood, the eggs and larvae right here. So now if the, yeah, go ahead. Oh, you got to unmute yourself. No, you're still muted. I can't hear you. There you go. Oh, it turned red for a second. Okay, so the nurse bees, I said, they run the show. Well, how in the heck can they tell what's happening outside if they're inside the hive? Here's the view that the nurse bees see from inside the hive. It's pitch black. There's no need for vision inside. They don't see anything outside. So their cues are all olfactory, what they smell. And what they can sense then is the smell and the taste of the incoming nectar from the foragers, the incoming pollen. So if there's fresh pollen being brought into the middle of the brood nest, they know that there's a pollen flow on. They know that they can start producing more jelly. They can tell how much honey reserves are out here because these nurse bees, they move all around the colony and they take assessment of the entire colony condition and they then produce jelly accordingly. And they also pay attention to the larval pheromone and to the forager pheromone. The place where the beekeeper wants to pay attention is right here, this interface between the stored honey and the brood. This is the dynamic interface where everything happens right here. So this is where you really want to pay attention to what's happening. So if you look at the capped honey, that's the energy stores for the hive. This is what they're going to use for staying warm or to get energy for flying when there's not fresh nectar coming in, this stored honey right here. Then there's a protein reserve, any stored bee bread, the surplus more than what they need to eat that day. Now they don't need this. They can have a turnover each day's pollen income in one day. They may not store anything. So this means there's an excess here. Then you have this huge energy and protein demand of the brood right here. And there's two key interfaces. The energy interface is right here, right between the pollen band and the honey. You're going to see either cells of honey being emptied or for the bees to use, so the colony is losing weight, or cells being filled with nectar to be cured into honey. And then the nurses will consume this pollen and they'll start working down and push the brood nest down and the colony will gain weight. And then the other one is the protein interface, whether or not you have a surplus here or not. So as soon as you run out of pollen in the middle, then the nurses will move over here and they will gobble up any of the stored bee bread. So you have an energy interface and a protein interface.
Okay.
Yeah.
Randy, can you hear me now?
Yes, I can.
How can you tell the difference between the fresh pollen and bee bread? Is there a look to them?
Oh yeah, let me go back a couple here.
Okay.
Okay, so the fresh pollen usually looks dry on the surface and has a fresh color. And see how the bee bread, they add nectar to it, they pack the air out of it, and it has a shiny appearance and changes color generally.
Okay.
And if you were to dig this pollen out, what you'll find is a whole bunch of layers of possibly different colored pollens in here because they pack in the loads from a number of different foragers and they mix the pollens up willy-nilly in the cells when they come in. The only bees in the colony that consume or digest pollen are the nurse bees. And if you're crushing bees, look for nosema spores, you'll tell easily. These are some nurse bees crushed, and you can see all the pollen coming out of their guts and making the water that you crushed them in cloudy. If you catch foragers at the entrance, even though they may be carrying pollen on their legs, their guts are free of pollen because they're unable to digest pollen. So the queen bees and the foragers do not digest pollen. It's only the nurse bees that digest pollen. And then they convert that pollen to jelly, and that's what they share. This is the shared currency. And because it's shared with every bee in the hive knows the state of nutrition of that hive, by how willing the nurses are to share this protein, this jelly, with the other bees in the hive. And then the foragers work accordingly. If the colony is getting short in protein, they will shift to foraging for pollen rather than foraging for nectar. So let's now, with that background, let's go through a year in the hive with the bees. So the year starts with the first cue, which is typically tree pollens. This is from one of my hives. This is alder pollen coming in. This is the first pollen that the bees have coming in the springtime. Most areas it's tree pollens rather than ground flora pollens coming in. This is a signal. It's time to start building up the colony in the anticipation of spring, because they want to get the jump on their competitors and start early in the season. So up in Manitoba, you see this happens in about March here, where they haven't been rearing brood, and you see the brood rearing start to increase right here. So here's a picture from one of my colonies in January. Little patch of nice brood right here. Look at this, they're loading it up with that alder pollen coming in if we have sunny days during January. And this fresh pollen stimulates the nurses to produce a lot of jelly, feed the queen, she lays a lot of eggs, and then the young brood hatch out, and the pheromone that they give off stimulate the nurses to really produce jelly and stimulate any foragers to go out and forage for more pollen. So this E-beta ocimene pheromone puts the colony in build-up mode. Now, this E-beta ocimene is a cue to all the rest of the bees in the hive that the queen is viable and laying eggs. So as long as there's E-beta ocimene produced by young larvae, the colony will not try to supersede the queen and does not want to swarm. It's when there's a break in the E-beta ocimene, the signal that cues for supersedure or for swarm preparation. It means the queens run out of room to lay eggs. There's no young larvae, time to start producing queen cells. So this is one of the ways to deal with swarm prevention. Then we get to the spring turnover. And the problem is, as these adult bees start rearing brood, they change their physiology from long-lived winter bees to nurse bees, and they're going to live for about 35 days. So their population is going to rapidly decline. It's a graph from Al Avitabile years ago. Yeah, I got it up there. Meanwhile, the amount of brood increases. If we take a look here, you can see here, these long-lived winter bees, which have had almost no mortality, notice the colony population did not change at all. Once they start rearing brood, they suddenly start to die off. And notice all this wide band of these blue winter bees just disappears suddenly right here, where the brood and the young bees, their population explodes. So this is the spring turnover right here, very critical time where if you have bad weather in the late winter, early spring, then you have colonies fail from an unsuccessful spring turnover. Once they start rearing brood, then all the remaining winter bees that are going to die soon from old age, they need to very rapidly, before they die of old age, recruit enough replacement bees to take their place. And as you see here, you're going to have twice or more many brood bees in the brood cells as you have adult bees taking care of them. And then if there's a bloom on and those bees start foraging, they wear their wings out. They only can forage for about 12 days, and then they wear out and they die. And this happens in almond pollination, where if you take colonies right out of cold storage, put them directly into the almonds, they can wear out from foraging so quickly that the colonies will then collapse rather than being able to build, despite all this abundant forage around. So here's a picture of a colony with minimal protein reserves. You see very little bee bread stored around here. They're all in. There's barely enough adult bees to cover this brood. So these are a bunch of old workers in January desperately rearing their replacements. And then we start to get diseases hit. Now there's a seasonality of diseases. So in the springtime, you worry about or late winter, springtime, you worry about nosema. Then European foul brood and shock brood in springtime. And then once the colonies build up, you don't see much European foul brood or shock brood or nosema. You may see American foul brood during the summer, but usually not much in the way of diseases during the summer. Late summer, then Varroa and deformed wing virus become a problem. And if they overlap with paralytic viruses during the winter, the colony is toast. And same with nosema. Nosema and any of the paralytic viruses are a bad combination. Then you start again with European fat brood and shock brood. So know your seasonality diseases when you need to worry about them and look for them. Here's a picture of 400 times magnification. This is a bee breathing tube, a tracheal tube. This is the gut tissue. You can see the striations in the gut musculature. Every one of these white dots is a nosema spore in the gut cells. So you can see how the bee's gut just gets hammered by nosema, which steals energy, suppresses immunity there. Here's a 3-frame colony in February where we're getting some chilly nights still, and they're stretched to the max. So this is the old winter bees with this beautiful patch of brood right here. One look tells me this colony is in big trouble because I already said it's chilly nights. That amount of workers could never have kept that amount of brood warm on a chilly night. So one glance at this frame tells you, oh my gosh, attrition is exceeding recruitment, that they're dying faster than they're running newbies and they're stressed to max. One cold night can cause these bees to chill. They'll form a tight cluster, and you can see the band of bee bread around here. That's how big this was. Solid brood a day or two ago. And you get one cold night and this cluster contracts. They let the brood get chilled. The next day they go in there, they cannibalize all the dead brood out from the chilling. And all these are old bees which don't have a chance of reestablishing that brood nest. Now, if I take these bees here and crush them one at a time, I'll find that 8 out of 10, maybe 10 out of 10 will be infected with Nosema ceranae. So this is a typical collapse from Nosema. Now we saw a lot of this in the early 2000s during what we called CCD. And the symptom of CCD was exactly the same thing as collapse from Nosema ceranae. So very strong correlation between CCD and Nosema ceranae. We don't see, even though people say CCD now, we're not seeing CCD. We're seeing Varroa virus collapses now, very little CCD. Here's another picture. This is what we saw during CCD. They talk about being left with all the brood just suddenly disappearing, the bees disappearing, and a silver dollar patch of brood left, bees left with the queen in the middle of it. This was very typical during CCD. We don't see this much anymore. Now, one more thing about Nosema, you'll see all the bee books have it wrong. They perpetuate this misconception that when you see dysentery in front of the hive, that means the bees have Nosema. Nosema has never, ever been shown to cause dysentery in bees. But if they do have dysentery and they poop within the hive, that will spread Nosema spores and can make Nosema more of an issue. So simply because you see dysentery, this is a water balance problem, that they have too much moisture in the guts and they can't hold it, and they're trying to fly out. Maybe they're confined by weather or something, and you'll see dysentery. It can also be caused by yeast infection or another infection, but it's not caused by Nosema. The only way to tell if you have Nosema in the bees is by putting them under a microscope, 400 times magnification. This is the little larger than 400 here. This may be 800 times, because this is the typical hair from a bee. This is a pollen grain, and all these little white ovals are Nosema spores. This would be Nosema ceranae, this typical shape right here. The only way you can detect, diagnose Nosema is with a microscope, not from looking at the entrance. And Nosema doesn't normally have that much effect on a well-nourished colony with a young queen, but it can slow a colony down if you have more than about 40% of the bees infected within the hive. If you keep young queens, Nosema is not usually much of a problem. And then the colony goes into the linear growth phase. And they can grow very rapidly when there's pollen abundant. And back in 1925, Nolan showed how rapidly package bee colonies can grow linearly at this incredible rate, about 500 to 600 bees a day, until they come into equilibrium at about 40 times the queen's egg laying rate. And you can see this linear growth of the colony increasing right here, same type of thing. Now, these bees can live hand to mouth. So this is us where we're putting a second brood chamber on these colonies that have just filled the first box right here. Of course, we'll smoke the bees off before we lower this down right here. But if you pull the frames out of here, these guys may be living hand to mouth. They may not have any honey reserves or any pollen reserves. And there's a very rapid turnover of the worker population. Roughly once a month, you're turning over the worker population. And this requires a huge amount of protein to replace all those worker bodies, about 1 to 2 pounds of pollen coming in every single week. So if we get any kind of rainy event, these guys are right on edge because they're living hand to mouth. Notice there's almost no reserve of bee bread. So that means they're eating all the incoming pollen every single day. And because they're uncapping this honey, that they're expanding up into their honey stores. And then it rains. Or you guys get those cold snaps back there. We get rain.
Yeah.
We can get rain for 30 days in a row during February, March, or April. And our colonies, within hours of rain, the nurses start cutting back on the amount of jelly that they feed to the larvae. They very rapidly adjust. And when I looked at the data from Lloyd Harris here, notice this dip in the brood production. I was curious about that, so I looked back at the weather history, and it showed that there was a cold rainstorm that moved in right here. And sure enough, they cut back, they'll cannibalize those young larvae because there's no fresh pollen coming in. Was that a question, Jeannie?
Mm-mm.
Okay. So this is a hiccup due to rain or cold weather. And within just a few days, a colony can cannibalize or consume all their honey reserves, all their pollen reserves. Then they'll cannibalize first the eggs, then the young larvae. The only thing they'll leave would be the sealed brood, which doesn't need any more feeding. And they hunker down and they all try to keep this brood warm so that you have some survivors. So this colony has not died yet. It's cannibalized. The whole bottom board is covered with cannibalized or removed brood. And these type of things happen when we have an unexpected snowstorm in the springtime. So many beekeepers are sitting inside during that snowstorm watching TV, and we're outside working our bees and feeding them to make sure this doesn't happen. So here's a picture of me treating my bees better than I treat my own children. These are my 2 sons. And when it's rainy and miserable outside in the springtime, this is how we dress. And there are times when we dress for 30 days in a row, working bees, wearing foul weather gear. And people say, Randy, you're out feeding your bees when it's raining and snowing? I said, well, duh, when it's warm and sunny, they feed themselves. If you're a beekeeper, that's your job. When your livestock are starving, you get out there in the rain and the snow and you feed them. So this is us feeding, emergency feeding of pollen sub to our colonies, brushing the bees out of the way with a pine bough right here so don't squash them. And this is how we protect our bees, keep them building up during the spring, working in the rain, in the snow. And we may also give them supplemental sugar syrup at the time to simulate a nectar flow, so they will continue to build up in preparation for the honey flow. Now you may want to do a hive inspection. Now, the bee books, they talk about going through every frame in the hive, one after the other. That is so disruptive. It kills queens, it pisses the colony off. Typically looking at one frame from the middle of the brood nest is all you need to pull out. So we'll open the upper brood chamber, pull the frame out of the middle and look there. Right here you see they got honey reserves. They got really good larval survival because you have a really solid brood pattern. Bees all look healthy. That's it. A 15-second inspection is all we often need to look at in a hive to say that everything's okay. But close it up and leave them on their own. This is healthy brood. Solid brood pattern means high larval survival. This is spotty brood. You have low larval survival. Something's wrong here. So early in the season, this typically would indicate European foul brood. Later in the season, it's typically because of pollen dearth. So notice there's no extra bee bread stored here. So that means that the nurses are cannibalizing the eggs, our young larvae. The queen can be laying it full of eggs every day and they'll just follow right behind her and they'll just gobble those eggs right up afterwards. They don't try to, if there's not pollen coming in, they're not going to try to rear a bunch of larvae. Uneven age of these larvae. Look at, we got old larvae next to fresh larvae. That means that these larvae have had high mortality and the queen comes back and lays an egg in. So uneven larval age is a sign of disease or poor nutrition in a colony. You want to have your larvae with an even step down of age. Here's chalk brood, very typical sign of this. You have this, they chew it off, you have this white body of the larva and this little brown patch right here. Very, very typical. You may see these mummies out on the landing board. There's generally no treatment, just if it persists, it'll usually go away on its own, otherwise just requeen the colony. This is European foul brood. We're seeing a lot more European foul brood this last decade. It appears to be evolving, and it doesn't act the way it used to. It used to just go away on its own when we got a nectar and pollen flow. We now see it persisting, and we rarely use antibiotics in our hives. But when we see European foul brood, yes, we do. We spot treat our individual hives with oxytetracycline, and it clears it right up, and then we don't see it. So we're very happy. Keep it. We don't use it prophylactically, but we use it spot treating and find that it'll take care of European foul brood. Generally, when you have mixed pollens, it's just like if you go to the buffet and you come back with a plate with every color of food on it, it's probably a pretty healthy diet. Whereas if you come back with just one color of food, it's probably less healthy. And the bees, there's no indication, even though lots of authors try to show it, no indication that the foragers have any idea how nutritious the pollen is. But what the foragers do is when they come back and they sniff the pollen coming in, they'll go out and seek pollen that smells different. And they get this mixture of pollens coming into the hive. And if there's a good mixture of pollens coming in, generally there's good nutrition. And you can see by the high rate of larval survival here, this was good nutrition right here. So here's nice step down of age of brood. This is indicating that these larvae are surviving, good nutritional status, plenty of jelly around the larvae. So if you see this colony is healthy. Ideally, you're going to see these larvae swimming in jelly, not the first instar larvae, but these second instar larvae, the second stage. And at second stage larvae, the nurses will cover the bottom of the cell entirely with jelly. If you see this, you are the world's best beekeeper. You could not kill this colony. This colony will survive anything because they're recruiting so quickly. So this is the number one thing that we do to see if there's nutritional stress. We just look for the amount of jelly being fed around these second instar larvae, especially late in the season. We watch this. If you want a colony to build up, if the nurses start cutting back on the jelly that they feed the larvae, that colony will go from build-up mode to survival mode. So here's a frame of larvae being fed just barely enough jelly to keep them alive. So this colony is not in build-up mode. It's going to go into survival mode. And the other thing is when these bees, the workers that emerge from these larvae, they have an epigenetic change due to that minimal feeding, and they will start foraging earlier in life and not live as long. So they will not be the worker that reach their full potential as a worker. So here's bees, plenty of jelly right here, looking good, healthy colony. And here's eggs being laid, but look at this, almost no jelly around the workers. So we found this is our number one thing to look at to a very quick nutritional assessment of your colonies. Okay, so now,
Randy.
Yeah.
And what would you do if you found a hive like that didn't have much royal jelly? Can you fix it?
It depends on what your goal is. If you want to keep building up, then feed them pollen sub. If you want them to go into a survival mode in the late summer and you're not interested in them building up, so in August, that's what we want. We want them to shut down the brood nest so they're not rearing varroa. But then in September, we want them to build up more brood to form the winter cluster. So we will feed them, starting September 1st, we'll feed them pollen sub. So that's our cue that in September that they're not getting enough nutrition in. So we're going back to the buildup mode, the swarming impulse. And that typically happens when the colony starts to top out on the amount of sealed brood in the colony, when they filled the cavity and they're ready to reproduce. They haven't reached maximum strength, but they filled the colony with as much brood as they possibly can. Especially when they start bringing in nectar flow, crowd the brood nest down, they run out of space, and the queen can't find room to lay any more eggs. And 3 days later, there's no young larval pheromone, and that's a signal to the colony, wow, no young larval pheromone, queen's out of room, we better start making swarm cells. If the beekeeper intervenes and it shifts some frames around, like maybe reverses the brood chambers to put some drawn comb directly above the brood nest, or even insert frames of drawn comb so the queen can lay, the bees will actually tear those queen cells down and avert the swarm impulse. So when they sense that they filled the cavity and packed the brood nest, there's no other reason to live other than reproducing. So they rear plenty of drones and they start their queen cells. These are drone cells here. These are queen cells here. And so you can manipulate the brood nest to protect swarming. This has been written about for many, many years on for swarm prevention. If you start seeing colonies look like this, it's too late for swarm prevention and too late to cut these cells off. You need to make splits. So split your colony up. We go into full production. We make about 200 nukes a day, every day during the springtime. We make about 3,000 nukes altogether, splitting our colonies. Here's a big tip right here. Don't split them where the colonies sat. So we take our colonies from the hive location and bring the boxes away over here. Any bee that's going to sting you flies back here to the original hive location. The bees that are left here are all young bees and they're still stinging. So now you can very easily look for the queen and make your splits here. And otherwise, they're going to go on to colony reproduction. So by splitting your colony, you can avoid them swarming. You can always combine those splits back at the main honey flow and then have a large colony to make a honey crop. So your colonies at swarming season, they're going to look like this. They're going to have tons of sealed brood. Well, the sealed brood is stacked like cordwood. You're going to have 3 cells of brood in the space that you have one adult bee crossways on that. So you get a 3-to-1 expansion. So 1 frame of sealed brood, when this brood emerges, is 3 frames of adult workers. So you have this explosive of bees. So when we sell our nukes, when we sell nukes, they typically have 3 frames of sealed brood. That means in a week or so, you're going to have 9 frames of adult bees emerging. So that nuke has to be transferred into a full single or even a double almost immediately, because this is going to explode in population. And what you're doing is getting ready for the main honey flow. Ideally, you're going to reach peak population right at the main honey flow. If you reach peak population early, the colony may starve. If you reach peak population after the main honey flow, you've missed out on it. Now you got a bunch of bees and not going to make as much honey. And the thing to keep in mind is the larger the colony, the more efficient it is at storing honey. So 1 really strong colony will store more honey than 2 medium strength colonies. So just before the main honey flow, we will combine our weaker colonies to make super colonies that will make huge honey crops. And then the flow starts. And you call this nectar shake. You pick up a comb, turn it sideways, give it a shake. This was taken like about 10:30 in the morning during our blackberry flow some years ago. And when you have a flow like this, boy, they can put on honey fast. You can have a colony gaining 10 pounds of weight every single day. And they will just draw foundation like mad. And what they'll do is they will plug out the brood nest, prevent the queen from laying eggs, and use all those brood cells for processing of the incoming nectar. Because any brood reared during the honey flow is of no benefit later on. And you'll start seeing when they run out of drawn comb to store that nectar in, they're going to start, that's the signal to start making white wax, start producing wax. And white wax means, as for the beekeeper, put more room in this colony or they're going to plug out or they're going to swarm. The other thing means this is the only time you're going to be able to draw a foundation when you see white wax. If they're not making white wax, it's a waste of time to try to get the bees to draw any foundation. There's no tricks to drawing foundation other than the colony producing white wax. And here we go, put that foundation in. And if you add foundation above a queen excluder, above a band of honey, the bees are very loath to work that foundation. You want to rotate some frames of brood directly up above the queen, right below the queen excluder, and then the bees will more readily work that foundation above that. It's easiest to draw a foundation even without a queen excluder directly above the brood nest. And the bees then maintain this feedback loops to keep roughly the same proportion of foragers as they have of mid-age bees, the honey processors and home builders. And I've written about this on my website. I'm not going to go into detail, but they have to maintain about a ratio of about 1 forager for 1 mid-age bee. And notice the deprioritizing of the brood rearing right here. So here's our brood, and look at this drop in the amount of brood right here. And what this happened at is right at the main honey flow right then. And the bees just fill the brood nest and prevent the queen from laying eggs for a while. After the honey flows over, they'll clean that, those transfer the honey out of those cells, and the queen can start laying again. So what you do is you trick the colony into thinking they have not filled the cavity and that they need to keep foraging for more and more honey rather than swarming. Here's Tim Ives out in Indiana. He makes these 350-pound honey crops, and he is surrounded as far as the eye can see, and I Google mapped it and I drove it from here, by neonicotinoid seed-treated corn and soybeans. He makes these monster honey crops out there. Okay, then after the main honey flow, then they're going to reduce the population. They don't want any more mouths to feed. So no pollen, that means the nurses say, oh, we're in survival mode. We want to stop rearing any more replacement bees during this pollen dearth in the late summer. So very little recruitment. And what you see here is that the attrition, so now you're in the negative numbers, you're losing 400 bees a day net, down to losing 100 bees. And because the queen's not laying as much, that 1,000 bee a day attrition very rapidly drops this colony population down, because you don't want all these extra mouths to feed. And yeah, so you can see with Lloyd here, the population dropping down right here. And you're going to look like this. You're going to see the freshly stored honey, white cappings, virtually no pollen anywhere in the brood nest, and a poor pattern with poor larval survival because the nurses are consuming the young brood. So this is a sign of protein deficit in late summer, which is not a problem. It just means that they're not, you don't want them to rearing brood there unless you want to keep them large for some other reason. Now, that means that you're also, those bees are aging in the colony. You can rejuvenate the colony, get them rearing young bees again by feeding with protein if necessary, trying to build the colonies up. And then the other thing you're keeping in the box is Varroa. So some of you are going to be better at being beekeepers, and some of you are going to be better at being Varroa producers, okay? And I have a downloadable model. Just Google Randy's Varroa model. It'll pop up. If you have Excel on your computer, you can enter it in there, and you can learn how to treat for Varroa and manage your hives for Varroa and avoid these crashes. I highly recommend running through on there. And it shows you what the mite wash count would be. And what happens is your mite level never really explodes. It goes up. But what happens is your infestation rate, your mite wash count, suddenly explodes not because the mites are increasing so fast, but because the bees population is decreasing. So you have more mites per adult bee. And typically you're going to increase from maybe 100 mites over winter up to maybe 10,000 mites in the hive if you haven't treated earlier in the season. And then the colony is going to crash later on. And let me go back one. The other thing the model shows you is the percentage. The red is, this is your amount of sealed brood in the hive. This is your percentage of sealed brood infested by a mite. When this reaches about 25 to 30%, then the colony is toast. It's walking dead. It's the deforming virus goes epidemic. So you want to keep this percentage of infested brood down low. Okay, so here's when you start getting high mite levels, you may see some Varroa sensitive hygiene, where the bees start chewing out virus infected pupae. You may see bald brood. This is one of the traits that we are breeding for resistance. This is the most common trait for mite-resistant bees around the world. Uncapping, recapping behavior. You may start seeing some bees with deformed wings, but mainly you're going to see the larvae and pupae starting to die here. And what's happening is, as your mite population, this is your mites per 100 bees, this red plot, it starts to go up. the virus prevalence in the workers. So this is deformed wing virus, and this is the paralytic viruses right here. Just track that mite population exactly. So when you're doing controlling the mites, you're doing vector control for the viruses. If you keep the mite level down, then your virus level stays down. And here we go, this tip point where you get too high infestation rate in the brood. And then what you start to see is you start seeing that the bees unable to emerge because of deformed wing viruses start dying with their heads sticking out right here. Maybe parasitic mite syndrome, where now you start seeing wholesale dying of the brood from high virus infections. Looks pretty ugly. This is a sign of too many varroa mites in the hive, and the virus is going rampant. And finally, if your colony suddenly depopulates late in the season, you can't blame it on the absconding. You can't blame it on swarming. Or in San Francisco, one of the San Francisco beekeepers said, "Oh, my bees ascended." So they just, but if you see these telltale white fecal deposits on the ceilings of the cells, that tells you that that's from varroa, that your varroa level was too high. And that's the most, any beginning beekeeper, you're typically going to lose your hives in your first few years from poor varroa management. And this is the typical sign right here. Here's another picture of those fecal deposits from the varroa mite. And then what happens is during the buildup right there of varroa mites, look at, here's a mite on this bee, here's a mite on this bee, and under their bodies there's even far more mites. These bees are the young bees in the hive. On their first flights often get lost and drift to other hives. Varroa prefers to be on the young bees in the hive. So this constant drift of bees from hive to hive, and I have hard data showing they drift a half a mile away at a very high rate. That spreads the mites to all the other colonies in the neighborhood. So you have a responsibility as a beekeeper to maintain low mite levels in your hives. Now, the most common mite management technique by beginning beekeepers is called wishful thinking. And wishful thinking, there's plenty of hard data, it has never worked. Varroa doesn't care about what you think. It's going to increase its population and will eventually kill your hive. Your best bet is to control Varroa starting early in the spring and keep this wash count down low all through the season. You never get above about a mite wash count of 10. Your colony will maintain health all the time. You want to be down to counts around 0 or 1 early in the spring. So right now, you guys should be out there making sure you're down to mite counts of 0 or 1. And then just if you're proactive and get them down now, it's way easier keeping them down through the rest of the season.
No,
yeah.
Randy, is that per 100 or per half cup?
That's per half cup.
So 1 per 300. Wow.
Yeah.
Okay.
Yeah, and do that early in the season. Here's what we do. This is our own California management for almond pollinators. I'm not suggesting this for you guys. We start off with a fairly low mite count in the wintertime because we've done an oxalic acid dribble. The mites start to build up when we go to almonds. Coming back, we split them. We create an induced brood break by requeening with a queen cell, and we give them an oxalic acid dribble day 18 after we make the nuke, and that reduces the mites way down. Then we're okay until about the 1st of July, and the mite count starts to climb. We still have honey supers on, so we hit them with 1 pad of formic acid, about a 50% knockback of the mites. And that holds us till we get the honey off. And then in August, we'll give them a thymol treatment, kill 90% of the mites, get down to very low mite levels again. And then we start feeding protein, build the colonies back up again. Mite counts start to rise, and then we give them an oxalic acid dribble going into winter. Notice we haven't used a synthetic miticide since the year 2001. And we run a successful commercial operation in California with 11 to 12 months of brood rearing. And this rotation has worked very well for us for quite a few years, since 2001. We're also looking at the long-term solution. We have a very strong selective breeding program for bees that can maintain mite counts of 0 or 1 throughout the season on their own with no treatment whatsoever. So we only breed, we restock all of our colonies only with these very mite resistant queens of very mite resistant colonies year after year. The issue is it's poor heritability so far. So we haven't gotten up to magic 90% resistance, but we're pushing 10% colonies being resistant, and we're sticking at this year after year. Okay, then when the autumn pollen flows start, again, the bees start bringing in pollen, and they'll start storing it below the brood nest for winter reserves of bee bread. And they'll get this brood ring. The brood that's reared at this time are the bees that will become the winter bees, the long-lived bees. So you can see this fall brood rearing in Lloyd's data right now. And this brood here are the bees that are going to form the winter bees. And what you can see here is the bees that emerge in July through September. They are very short-lived. They live for about 35 days. The bees that start emerging, this is up in Manitoba, that start emerging in October, they are, what did I just do? Current slide. They're the ones that are winter bees. They have a very very high survivorship through the winter until they start rearing brood in March, and then they die very, very quickly. That's where you need your spring turnover. So you want to extend their longevity. So you want to rear these winter bees late in the season. So this is when we're going to feed pollen sub in order to get this last cohort of bees that will become the winter bees raised. So first we control the mites, and then we'll feed pollen sub. Now you guys, if you have a fall pollen flow of goldenrod and asters, you do not need to feed pollen sub in the fall. Out in California, we don't have that, so we do stimulate this late season brood rearing. And any colonies that don't consume their pollen patty, we just close them up and walk away. Don't waste time. They're not worth your effort from that point on. They have an issue. They're either a poor queen, a failing queen, they're sick, but something's wrong. If they don't eat the pollen sub, they're not going to make it through the winter. And then your first freeze. First freeze means no more pollen coming in, and the bees will very quickly cease brood rearing. This happened in October up there in Manitoba when there's no more pollen coming in. And those bees that then emerge there, when they come out, there's no pollen coming in, there's no larvae, there's no larval pheromone. That tells them to go into survival mode, fatten up, create their fat body as much as they can, and hunker down to sit it out during the winter. So here's a nurse bee with the fat bodies, our winter bee, fully developed, as opposed to the foragers, which have very few fat bodies. So this is and the fat bodies are very important, not only for food reserve, but for many metabolic and immune functions. And this is the food of the varroa mite. They do extra oral digestion. They squirt in digestive fluids into the bee's abdomen and digest these fat bodies, and then they suck up the juice. So it really hurts the bee's immunity too. Then the fall turnover. Okay, right here, where you have all the summer bees fly off from old age and die. Now these newly emerged bees right here, instead of going short-lived, they become long-lived bees right here. You can see them up in Manitoba. They're already 74 days old. They're 97 days old. You didn't get any bees this old ever during the summer. And another point here, come November, you may have 50% of the bees fly off and die, all your summer bees. So you get this big drop in colony population in November, and that's natural. Then they form the winter cluster, and it looks like it's uniform, but it's not. If you give these guys a puff of smoke and wait a couple of seconds, you'll see there's a tight shell of insulating bees around, but in the middle is tropical, and these bees can move right here from this warm tropical area here. I have an article that shows how this insulating shell is formed. This is held at about 50 to 65 degrees Fahrenheit, whereas the core is usually at 65 to 85, or if they're rearing brood, they'll bring it up to that 95-degree temperature. And they ventilate moisture out of the bottom of here. So make sure your hive allows the water to run out of the bottom of the hive, and they maintain a healthy brood nest here. And you'll have these heater bees in here that will regulate the temperature of this core, whereas the bees on the outside, they just keep it around that 55-degree temperature. Notice the melted snow on top of these. If you provide top insulation, that's the most important place, far more important than side insulation on the colony. So you want to help your bees. And if you put something like straw or blankets there, that's not insulation because it absorbs moisture. And if it's full of moisture, it doesn't insulate. You want something dry. So styrofoam works really well. 1.5 inches of styrofoam for insulation over the top. And now you see these long-lived bees being formed all through the winter. And notice the low rate of attrition until they start rearing brood again. So these are your critical bees to get through the winter. And you can see they go into the winter, the last little bit of brood right here, very little protein reserve. Now, in the midwinter, they may initiate some brood rearing. See this here? And this is poorly understood, but it may be a function of moisture balance. So if a colony, if all their guts start getting full of too much moisture from the metabolic moisture from the honey, they may initiate brood rearing so they can take that moisture out of their bodies, turn it into jelly, and put that jelly in the brood. That allows the bees to get rid of that moisture if they're unable to go out for defecation flights in cold weather. And then the beekeeper can stimulate late winter brood rearing if the bees are able to fly during that time. Here's my buddy Keith Jarrett, and he feeds heavy with pollen sub during the winter in our mild California winters, and has these huge colonies that he actually shakes bees from in January and sells to other beekeepers whose colonies are too weak to go to almond pollination. So he has a surplus of bees in January from feeding pollen sub over the winter. And then we go back, first pollens start coming in, first few pollens, they start rearing brood here, they start dying off because they're shifting nurse physiology, and the cycle begins again. So we're back to where we started. And hope this helps you with understanding beekeeping. Recipe for healthy bees: young, vigorous queens, good nutrition, control varroa all year long, minimize the toxins, and be proactive. A lot more information at my website, scientificbeekeeping.com. And I will turn it back over to you, Jeannie.
Well, thank you. You know, I was remiss in introducing Randy. For those of you that are new beekeepers, Randy is well known throughout the country and does quite a lot of speaking when we don't have COVID issues at conferences and such, and does research. Now, is it my understanding with grants from various places and the government and
No, all my research is just from donations directly from beekeepers.
Wow.
Yeah, I don't apply for any grants. I don't accept any money from corporations.
Right, but you do have some kind of permission from the government to work with certain things that aren't.
Oh yeah, I have in order to work with the like extended release oxalic acid, I have a pesticide experimental use permit from the Department of Pesticide Regulation.
Okay,
so I can do that. Yes.
Yep, and you do send your bees to pollinate.
Yes.
Correct. Yeah.
Yes.
So he's quite the beekeeper and quite full of just incredible knowledge about the bees. Questions? You can either unmute yourself, or if you have quiet background, or put something in the chat if you wish, and we can take some time for questions. Anybody? There we go. That was so fascinating. I've always wondered how you tell the pollen from the bee bread. So that's good to know. I'm going to have to go out and practice that. So, but wow, lot of information and a lot of stuff to digest.
Yes, I know. It's information dense.
Yes. And your voice survived. So that's a good thing. That's great.
A good thing.
Anybody? Oh, I've got something. Go ahead. Yeah.
I just wanted to say thank you, Randy. It was awesome. Just a
you're
lot
welcome.
of great information. Really enjoyed it. Thank you so much.
Yeah, it's interesting trying to distill a lifetime of learning about bees into an hour.
Yes, it is. It's hard.
Well, we've had a very good spring here in Ohio. So very happy with how things are going so far.
Wonderful.
Well, thank you again.
Yeah. Yep. Anybody?
Don't be shy. I'm happy to answer questions.
Real quick question. You said you were making a couple hundred nukes a day in the spring and end up with what, 3,000 or so?
Yeah.
How many colonies did you overwinter to make 3,000 nukes? And keep, I assume keep some. Okay.
Yeah, and then we sell, we take about 1,000 bee hives to almonds. Then we sell 1,000 nukes. We sell about 1 nuke for every hive. So like we took 1,200 bees to almonds this last year. We sold 1,200 nukes, which means we have to draw 5 frames of foundation for every nuke that we sell. So our business model is to buy pre-assembled frames for $2 in the spring to replace what we sold in the nukes. And the next year we sell them for $30 a piece in a nuke. So that's the value add. So half of our income comes from almond pollination and half comes from nuke sales. If we can make a honey crop, because we're not in a big honey area, that's profit.
Great. So your focus is almonds and nukes rather than honey, which is a little different maybe than other people. Yeah.
Yeah, because we're not in a big honey area.
And we've heard people say, you know, you can either raise honey or you can raise bees.
Right.
So, yep.
And actually raising bees for us is much less work than raising honey. There's actually a number of California commercial beekeepers who don't even own a honey extractor.
Yep. Well, I think we have a few people in this club. Go ahead, Janet.
Do you have a queen rearing operation going?
Oh yes. Oh yeah. No, we typically graft. We're pretty small scale. We graft 300 to 500 queens a day during the spring.
Wow.
Could you maybe come back and do a lecture on that for us?
Sure.
Oh, that'd be awesome. Okay, good thought, Janet. And then do you use those queens in your nukes, or do you have the nukes make their own?
Oh no, and we control all of our who our queens come from, because we're in that selective breeding program for varroa resistance. So a colony has to be gentle, productive, and varroa resistant in order to make it into a breeder. And then we breed off of about typically 25 of our 25 best every year to maintain genetic diversity.
Okay, but my question: are you selling queens as just the queens,
No,
or are you using those in the nukes?
In the nukes, yeah. Okay. We sell a few queens, but most of all the queens go into nukes for ourselves. Ourselves are once for sale. There's no difference between what is in our nukes and what we use for ourselves.
Okay.
So what are you finding is how are your bees varroa resistant? What is their method?
I have not investigated that, but from what I observe, it looks like this is uncapping, recapping behavior. There may be other traits there, and we don't know. It's not like obvious. You look in there, but we have, like last year we had well over 100 hives that were essentially varroa free for over a year. They don't get moved in special yards. They're right there in the rest of the operation, but they just never needed a treatment. So we monitor them about once a month with a mite wash, and they just keep those mite counts down close to 0. And they're often the most productive hives in the yard because they have low varroa levels and gentle. We don't see any trade-off in selecting for varroa resistance.
You know, what we're finding here in Ohio, Randy, and several people in clubs around us are really into this, is that the feral bees in certain areas, including areas that our club members live in, have mite chewing behavior, and they're using the DM4 microscopes to look at mites that, you know, they find in a mite kill or in mite drop, and counting, you know, how many of them have chewed off legs. Yeah. But they seem to be developing that trait. So there's a big push in our area to go out and get swarms.
Absolutely.
To add to our apiaries. So
yeah, find out. I mean, because we humans we beekeepers, by treating from Varroa without doing a concurrent breeding program, have just prolonged the agony of Varroa. Left to their own devices, it doesn't take that many years for bees to develop resistance to Varroa on their own. So we essentially slowed that whole process down for it's over 30 years now. So the feral populations, they've been working in evolution.
You think that we've slowed it down by developing these chemical treatments? Is that what you mean?
Oh, exactly.
Or,
Yeah. Because we keep our commercial breeders keep propagating bees that are not resistant, and selling millions of queens from non-resistant stock every year. So that just slows down the evolutionary process.
Right. Well, and we're really pushing nukes, to replace, loss or for new people. We have a lot of our members this year were selling nukes, so that's a
Cool.
great thing. Yep. Anybody else? Got a quiet group tonight.
Yeah, you sure do.
I think we're all tired.
Oh God, I had a group a couple of nights ago. We went for a full hour of nonstop questions.
Oh
questions
my
and answers
goodness.
afterwards. Yes.
Yeah. Anybody? No?
Well, I want to thank Randy for doing this Zoom.
You bet.
We had you as our guest before COVID.
Yeah.
COVID. And we, as a board, we recognized the fact that this was going to change the way we did meetings.
Yeah.
We actively solicited other speakers that turned us down flat at that point.
Wow.
Now they're doing Zoom.
We felt like we had a jump on things. We invited, when we had you last February, we invited presidents from the other clubs in our area to come and see how it was done. And we were fortunate because we meet in a church that has their room outfitted for, virtual stuff. They have big screens on the wall and internet connection and all of that. So we feel like we got to jump on things, because when COVID hit, then we only missed one meeting in March. And then we just decided, well, they're going to shut us down for a long time. We're just going to get on this. And as Dan said, we had several, well-known speakers turn us down. I don't do that. I'm not doing that.
Yeah.
And now they're doing it all over the place. So
what actually for me, it is a huge benefit. I mean, in the last few weeks, I have spoken. I just spoke to beekeepers in Peru over the weekend, beekeepers in Scotland, beekeepers in England, and then all kinds of states around. So without having to travel, I can, and with no carbon footprint, I can sit here, walk in from the bee yard and my research I'm doing outside, give a Zoom presentation, go right back to research after that. So that is actually a huge benefit.
Well, and I agree. And I think, we have several members that have said they have been able to attend meetings they would not have been able to attend if it was in person, because they work till 6 o'clock and they're dirty and sweaty and they don't have time to take a shower and change and eat and get to the meeting, but they can walk in dirty and sweaty, grab a plate from the kitchen and sit down in front of the Zoom presentation and be there. So I think we will probably continue
That would be me.
to do. Yeah, that would be Jason. Yes. You and a couple of others.
Dinner.
Yep. With his kids sitting with him, but I think we will probably continue to Zoom even live meetings.
Oh yeah.
Because then people can, that can't make it can see them later. So, and I don't know how, go ahead.
Oh, I didn't mean to interrupt.
No,
I had a question that I don't want to forget. You mentioned that after making these splits in the spring and swarm season, getting through swarm season, you do a recombine to build the population up for a good honey crop. Or, well, apparently you're not going for honey, but that's a possibility to do. How do you time that? When do you know it's okay to build up that population?
It's not that we do a lot of recombine, but any colonies that have not are Are you familiar with the Pareto principle, the 80-20 rule?
Mhm.
That you can waste 80% of your time with your 20% of poorest performing, and your 20% of your best performing is going to make 80% of your profit.
Mhm.
So what we take is the poorest performing 20%, and they get combined with somebody else because they're not going to make us money. But by adding that population right as the honey flow starts, and when the honey flow starts, bees combine very, very easily without fighting. Just put them together like any that are still in singles that haven't built up to doubles. When the honey flow starts, boy, just put two singles together, let the bees figure out which queen to keep, and they'll have a honey producing colony
Oh,
rather
wow.
than laggards.
So you don't even pinch the queen.
No.
Oh, wow. That saves some time, doesn't it?
Oh yeah. Commercially, you do things as simply as possible.
Yes.
If you look at how we do things, here's the thing. What I see is beekeepers can take the simplest set of instructions, and they just will make it more time-consuming, more costly, and more complicated than it has to be. Our beekeeping is so simple with the minimal amount of equipment, the minimal amount of intervention, minimal amount of opening colonies, and our colonies thrive.
Mhm. Do you try to keep, we heard from another large, commercial beekeeper that they try to keep all their hives kind of the same
Yes,
size, so that the work you do is just very repetitive and
exactly.
quick.
Yeah.
So, okay.
You look for the outliers. So you walk into a yard of hives, you can walk right down all the hives and you heft them all. Any that are not gaining weight equal to the rest, those are the ones you deal with.
Mhm.
The unusual ones that way. So you manage your bees on a yard basis rather than individual hive basis. And yeah, you try to keep them all about the same.
Yep. Yep. Well, and I just want to give a plug quickly to Jason England, who we can see here, who is speaking. He has is raising native Ohio pollinator plants at his greenhouse. So if you want to plant some food for the bees in your yard, go see him. Pleasantville,
Right.
on Pleasantville Road. Is that where you are, Jason? Yep.
Yeah, 1700 Pleasantville Road. It's
Yep.
not 188. That's County Road 17,
Okay.
which they're both called Pleasantville Road. So
Oh, right.
and,
Okay.
and they intersect, which makes sense.
Well, Google Maps found you for us, so it worked.
Very good.
I have a question.
Yeah.
Yep.
What do you do about laying workers?
Laying worker, we just simply pick that box up and put it on top of a queen right hive.
Oh,
Okay.
You take the lid off, you take the bottom board off, you put one right on top of the other. And that takes care of the
interesting.
problem.
Good to
Yeah,
know.
we don't look inside, we don't do anything. Yeah, really easy.
Wow. Easy peasy. Good stuff. Anybody else? Now, Randy, I'm going to ask you something. I know that you were saying that we can sometimes really just look at one frame, and we do that. I mean, as we're 10 years in, and of course, we're telling our new beekeepers, inspect your hive every week.
Oh yeah, with newbies, like when we're selling nukes,
Mm-hmm.
we have our nukes. We bring them. We have pickup days. And we have them marked for between strong nukes and weak nukes.
Mm-hmm.
And the first question they ask is, "Are you a new beekeeper or not?" If you're a new beekeeper, we give them a weak nuke. The last thing a new beekeeper needs is a strong nuke because it's going to be a big hive really fast.
Yep. Yep.
So we give them, we don't even explain what we're doing. It takes too long. We
Right.
just give them weak nukes, and the experienced ones, they get nukes that have to be put into a single by the next day or they're going to swarm, okay?
Yep.
Because they're big. If you're a newbie, you can be in there every other day. That's how you learn.
Yes.
In a small colony while it's growing. Spend lots of time going through those frames. You're going to kill queens. You're going to make every mistake imaginable. But that's just part of it. Now, also when I go out and like when I give demonstrations when I'm at other groups, we'll do field work and I'll pull that first frame out and say, "Oh, this colony has European foul brood," and they say, "Oh, how can you tell?" I go, "Oh my God, I can't see a single symptomatic larva. I may have to go through 5 or 6 frames, I'll say, oh, here it is. Here's a symptomatic larva with European foul brood. But I can tell from the look at the first frame that the colony has European foul brood. There's this distinctive look to that. So a lot, and
But that's your experience, though. I mean, years
and
of.
when my sons grew up with bees, they would open a hive and they'd say, Dad, something's not right with this hive. We have no idea what it is, but something's not right with the hive. They could tell. And then I'd get over there. We'd go through the frames until I could point out what it was. So that's an experience thing. So there are times when you're going to go through a number of frames. If you suspect American foul brood, yes, you're going to look through a number of frames to look for the distinctive caramel colored larvae or the perforated capsules, because you don't want to keep, if there's any American foul brood, we burn all the frames in that hive without question. So American foul brood, we would do much more deep inspections. If we're looking for a queen, we may have to look at every frame. But in general, if a colony is thriving and we just want to confirm that there's nothing happening, a frame is often all you need to look for.
Right. So for those of you here that are new, I know we have a few of our new beekeepers. Really going through it every week is for your benefit.
Absolutely.
More than anything. It's so you learn, so you can see the changes from, one week to the next and start to understand what you're seeing.
And it's very hard to learn in a big, strong hive. Yeah. You want to start with small. I would rather start with like 3 2-frame nukes and be in them all the time for the learning curve, because the only way you learn is by looking at a lot of frames over time, seeing how they develop, how they expand the brood nest. That's the most fun part of beekeeping. Just having huge colonies making honey, that's just work. Having small hives that you can get in there and enjoy. And small hives don't tend to be defensive. They're just much easier to work with. So with the newbies, don't try to go for the huge hives. Get those small hives and get in them all the time.
Right. Well, we did a presentation for we're running a monthly sort of a virtual mentoring through the Ohio State beekeepers for new beekeepers. And they present once a month on a Saturday morning, first Saturday of the month, and the topics are everything you need to know for that month to do in your hive. And one of them was on, breeding frames. And we kind of went at it from you're kind of like a CSI detective, and you got to look at this frame and figure out what it means. And, you might find a frame that the brood has several holes, and uncapped. So, that you don't always just jump to the assumption that that's something wrong. Maybe it's their hygienic behavior and they're getting rid of bad cells, or if you find a completely empty cell in the brood box, well, maybe the queen's up in the next box, so it could be a good thing, it could be a bad thing. You have to kind of look at one frame and then compare it to the rest of what you see. Right. So
and what I see is this is very similar to walking into the office of an experienced doctor who takes one glance at you and immediately diagnoses the problem. Okay. And that's only from experience. They had me once at back in New York at they got 3 of us beekeepers, experienced beekeepers, to train hive inspectors. Okay, so we each had a group of us, and we were supposed to rotate the group going through hives. And I go through, I pull a frame out, and say, okay, so I take one glance, say, okay, what's the problem with this frame? And they would look and look and look. Well, it was kind of embarrassing because after a little while, everybody abandoned the other two instructors, and everybody, including the instructors, was around watching me go through all these hives, because I could spot in a second what the problem was, and they could stare and stare and stare, and until I pointed out the problem. And what I learned from that is the eye gets trained to ignore normal and pick out the anomaly.
Yes.
And the only way you can do that is by looking at tens of thousands of frames to train your eye to ignore normal. It's those pictures in the bee books of all the healthy frames, you ignore all that, and you look for the one aberration, the one cell out of the whole frame that looks wrong.
I have a greenhouse business, Randy, and when I take people through tours of the greenhouse, they rant and rave about how gorgeous everything looks, and all I see is that one over there that's got botrytis on its stem, and that one over there that's crooked, or, and the tags out of this pot over here, and It's
Yes.
just the way it
Yeah.
is.
Right.
Well, and that one of the things that I know Sam Ramsey says a lot is that, we've trained people to think that the varroa mite sits on the back of the bee or on
Oh,
their
God,
head.
yes.
And he said that's about the worst thing. Every single picture you find when you Google it looks like that.
Yes.
And he said the problem is they're only there about 5% of the time. The rest of
Right.
the time they're hiding under the plates. And it's a true statement that when you see a mite, it's too late.
It's too late.
And that's the same kind of thing where you just get trained to think that that's where it's going to be and that's where to look.
It was
So-
interesting visiting New Zealand. I visited New Zealand a number of times. Asked they came in with varroa mite, and I said, it's just like deja vu every time I go there. You're about 10 years behind us, and you guys are asking all the same questions that we asked 10 years before. And I said, so how do you? And they typically have a manager for every 1,000 hives in the operation. So I talked to a number of the managers. I said, so what do you do for varroa management? Because deformed wing virus had not yet established at that time. Oh, when we start seeing mites all over the back of bees, it's time to do a treatment. I said, enjoy that while it lasts, because that's not going to last very long. And sure enough, in a few years, it no longer lasted. And they're asking all the right questions then. But yeah, by the time you start seeing mites, it's too late.
Yeah. Well, and that's the big thing that we try to really, hammer to our new people. Not only, test, but retest after you treat. You've got to know what the population of your mites is.
Yeah.
So, and this is one of my big pet peeves is that in new beekeeping classes and for a long time in bee clubs, nobody ever teaches about winter bees.
Mm-hmm.
And I really didn't know and understand about winter bees until about 2 years ago.
Mm-hmm.
And that really made me understand the mite issue even more.
Right.
And how they destroy your hives over the winter.
Yep.
So.
And I have a friend who was managing hives, brokering bees for almond pollination. And he had a semi-load of bees show up one day. And the driver got out and started untying the ropes. And my friend said, why bother? And he goes, what do you mean? He says, looky here. You got bees with deformed wings crawling out of all the hives. You just hauled these bees, this semi-load of bees from the Midwest here to California, and none of these are ever going to make it into almonds in a few months. They're all going to die over the winter. You just wasted your whole time.
Wow.
Yeah.
Wow.
So when do they bring bees into California to pollinate almonds? Apparently,
a
well,
lot of
before bloom
people
time?
bring them in before it starts snowing. So about a half the hives in the United States are up in the Dakotas during the summer. So a lot of them, it's just in November, it's just semi-load after semi-load, sometimes even as early as October, of bees coming over the Sierra down, and then they put them in holding yards, which is really rough for the bees.
Oh, wow.
And then other ones, they keep them in cold storage, and then they bring them out in spring, and they'll bring them out about 2 weeks early, let them fly. And when you bring them out of cold storage, that first day of flight, it's just like taking a shower in bee poop. It's like standing in the rain. You go, pop, 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 you just feel the drops all over you. You're just covered with bee poop. So those are the two things. So it's usually either side of winter. Either it's in the fall they come out into holding yards, or the spring out of their storage barns and bringing out. Those of us who are resident, it's a whole different thing. We don't even we don't do heavy staging at all. So we actually typically have a nectar and pollen flow, if the weather's right, shortly before almonds, and we have to move them off of a nectar and pollen flow down to the desert before the trees come into bloom. And so we have to give them a pollen sub when we set them down, because they're coming from a nectar pollen flow into a desert for a week before the trees bloom with nothing to eat. So of course, the growers, they want to see you put the bees in there early to prove that you actually have the bees. we want to wait till the last minute to keep them on that free food.
Yeah. Well, how long does the bloom last then?
A couple of years ago, we had growers call us 7 days after placement to take them out.
Oh,
Well,
wow.
it was a flash bloom, which means all 3 cultivars in that orchard had bloom in that 1 week. Other years, when the weather prolongs the bloom, you may be in for over a month.
Wow.
A month's still short. That's
Yeah,
amazing.
that's a long haul for
Yeah.
that. But
Yeah, but we are, you know, we go in on contracts where we get paid a premium for a string. So we have high contracts where we make $225 a hive. You make $225 for a week's rent of a hive. That's pretty good
yeah,
money.
that's pretty good money. Yeah. Yeah. Wow. That's
Yeah, with
interesting.
1,000 hives, that adds up quick, doesn't it?
It adds up very quick. Yes.
That's great. That's awesome.
Yeah. When I handed the business over to my sons, I had a handful of those checks from the almond pollination, and I said, the important thing to understand, guys, is do not confuse cash flow with income.
Yeah.
Because
How true.
I'm handing you $250,000 worth of checks. And I said, you're going to spend most all of this money before this time next year.
Yes. Yes. Oh, wow. How old are your boys?
They're in their late 30s right
Oh,
now.
really? Okay. I didn't realize they were that old.
Yeah.
Wow. Wonderful. Well, so
Yeah,
you
they're doing very, very well, trying all kinds of new things out. And I tell them, question everything,
Mhm.
try new things, experiment. They have the benefit of my experience. So from time to time, I'll say, I suggest, I don't ever tell them what to do. They make the decisions. I say, based upon my experience of what I've seen happening, you can avoid a disaster by doing this right now. And
Yeah.
when I say something like that, they listen and they
Yeah. Good
avoid
for
this.
them. So are you getting a little bit of retirement downtime, or are you filling it with other things?
Oh God, no, I'm busier than I've ever been. No, I have a list of research projects just screaming, because the research scientists from the universities, they're not interested in applied research. Applied research is
Right.
not good on your resume.
Oh,
And I've
that's
got all
interesting.
these applied research projects that are just,
Yes.
dying to be done.
Yes.
And interesting, I did a big trial of pollen subs, testing all the pollen subs this last year. I've just sent off the first 2 articles just today. I just got for a publication. And after we got all the results in, and I could rank the pollen subs for our performance, I could look at the amino acids and have on a spreadsheet, and I could predict with 85% confidence how they would perform. So I developed a calculator I'm going to put out for free to anybody who's interested, all the manufacturers. Said, you want to see how your pollen sub is going to perform? Enter your formula into here, and it'll show you on a graph where you're deficient. And
Wow.
so this could be a big breakthrough on improving pollen subs. To me, that's the exciting thing, helping the beekeepers and the manufacturers to develop better products for us.
Yep. Awesome. Well, we really appreciate that. All the knowledge that we're, getting, and that's the other great thing about Zoom is that we don't just get local beekeepers doing presentations. We get college, professors and grad students and you guys, the commercial guys, and you particularly that's done all this research. It's just amazing to have those resources now at our fingertips. So
yeah, way cool.
Yep, we enjoy it. So anybody else have questions or comments? No, don't even see half of their smiling faces. And Dan, is there anything you wanted to mention about business, or do we want to go through anything that we talked about at our board meeting?
Okay, I'll tell you what, I'm gonna sign off then.
Yeah, Randy, absolutely.
Hey, Randy.
Yeah.
I'd like to just say one more thing.
Yeah.
We love you. We've been watching you for years on scientific beekeeping.
Yep.
And I love to listen to a speaker that makes a living and with sons doing the job.
That's awesome. That's awesome. Yep.
All right. Thank you, Dan.
Well, we appreciate you. We're really glad that your health is improving, and hope that stays that way, and you keep getting better. And
all right,
we're gonna
I visited the doctor this morning, and he said things are looking good. So I'm very happy.
Awesome. Well, hopefully pretty soon you'll be able to taste that honey.
Yep. All right.
All
You
right.
take
Thanks
care,
a
guys.
lot, Randy. Okay.
All right.
Thanks.
Thank you.
Again,
Thanks for your time. Awesome.
Good night.
I don't know how interested people are in just knowing a little bit of, where the club is going. I don't know how many of you heard that Father Pete said that the church is ready to allow us to meet in person in the building with no restrictions. So that's something that we'll be looking at. I think we'll still meet in June at Rising Park. That'll be just a nice, way to kind of ease into it for those people that are comfortable getting together, mask or no mask. It doesn't matter to us. But maybe in July and August we can move back into the building if people think that that's an okay thing. My only concern, and I wondered if he would restrict us, was the amount of crowd that we have had. We've been every seat filled almost back to back and elbow to elbow. So I don't know whether people are going to feel comfortable with that or not, but according to Father Pete, there are no restrictions. So, Dan, what else? We have Kim Flottam's going to talk next month on swarms. Not next month, I'm sorry, in July. Next month, everybody's supposed to bring a gadget. Could be a cool gadget you've found and bought. It could be something you've built or made or designed or improved. But we'd like everybody to bring a gadget if you have something or more than one. Dan, what else do we need to?
I just want to bring up the bee yard again.
Okay. Yep.
I just loved it when Randy said, "Oh no, you got to get in them
Yep.
more often than not."
Yep.
You don't have to stay there all day,
Mhm.
but you need to be looking at your bees.
Mm-hmm. Well, and the bee yard is being run by volunteers from our club who are volunteering their time to be there. And the purpose of the bee yard is to help people learn. You don't have to be brand new, but we encourage our new beekeepers to go when you can. I mean, they're there every Thursday night now at 6 o'clock. And we are getting nukes at some point in the next couple of weeks as well. So they'll be installed and we'll be able to look and see the difference between a nuke and a package as they grow. The only thing you have to do is bring your veil, and gloves will be provided, and you can watch or participate as you wish, and learn from other beekeepers. So the only other thing I can think of is that we've talked about Lancaster. The county of Fairfield has a grant program that I think was established by it's a foundation that was established by a family, and they have a lot of undesignated funds, and they accept grant applications 3 times a year for community type things, and it can be anything. I mean, they've donated to the Y, to individuals to plant a garden or all kinds of things. But we thought maybe we would apply in their second round, which where did we decide? It was in August or something to apply to see if we could fund maybe three students in either 4-H or what's the one in high school, guys?
I don't know.
FFA, and provide their of course they could come to our bee school, and then we would provide 2 hives and the bees and the tools for them to get young people started. So that's something that we've been kicking around. So anything else anybody can think of, John? Or
Yeah, we just finished a weekend down in Hawking County at their Ag Days. We had lots of people visit our display. We signed up, was about 5 people that are interested in being contacted
about bee school. Yeah.
School. I think we're going to come out with about a couple $100 worth of profit on the honey that our club members donated to us. Well, I guess we paid $7 a pound, and we were selling most
Right.
of it for 10.
We paid them wholesale and sold it retail. Just to,
Yeah.
you know, one of the things that we have to watch with our funding is that when we were meeting together, there were a lot of fundraising things going on. You know, there was a raffle every meeting, and we had the big auction and things like that. We sold T-shirts, so we still have, you know, small profits coming in from the woodenware sale, the winter hive boxes that went on top, things like that. But you know, I think we started out the year with about $9,000 in our account, and I think we're down to 6. So, you know, we just have to be mindful of that and find some other ways to do some fundraising. So if we are allowed to go to some of these fairs that are possibly going to take place, and you know, sell on consignment people's honey, or invest in some honey sticks, things like that, then we can make, you know, $100 or a couple $100 an event to keep our kitty going, so we don't run out of money. Some clubs around the state are really struggling, especially if they were small and they didn't have a lot of reserve. And OSBA has provided a grant for clubs that have less than $1,000 in their account to get some funding from OSBA. So that's been a great thing from them. But we're doing okay, and just you know. Go
What
ahead.
are the major expenses? Just
Well, speakers, of course, they're not a major expense anymore, because we
you
pay
don't have to
Randy
pay transport.
$50. You know, we don't, yeah, because usually the travel is twice that usually, just for gas, or the IRS mileage allotment or whatever. So that's and equipment for the bee yard would probably be the other thing. And this, you know, the Zoom contract for the year is less than rent. So, you know, that's not a real big, I mean, I think the Zoom contract was like $109 for the whole year.
And our OSBA affiliation.
Yeah, we have to, but that was waived this year though by OSBA. So we typically probably would have paid about $150 for our affiliation, and that provides us the liability insurance for all of us, and the officers and such, and the church. So that was waived, and that's coming to us, you know, free from OSBA this year. And their speakers, when we use their traveling speakers program, and we've heard most of their presentations. They have a new one on Varroa that we have asked somebody to do, and I don't remember when that is, but
Linda
you know,
Smith still on here?
Say it again, Linda?
Yeah.
I don't think so.
Oh, she did a presentation to a group on beekeeping.
Mm-hmm. Yep.
We've done presentations with the was it Girl Scouts or
Mm-hmm.
Mary?
We haven't done it yet.
We have some pending, yeah.
Yeah, Girl Scouts are pending now,
And the Y
and the YMCA
is
gonna be
pending,
part of their summer program.
and that's for kids.
We
So
received a couple invitations from people that were at
mhm,
Hawking this past
mhm,
weekend
Yeah.
that have festivals they want us to try and set up at.
right.
We just got to remember it's
Yeah.
you know, it's a joint effort for all of us.
Yep.
We're talking about maybe coming up with some kind of incentive that if you you know, you participate in these and man these booths a certain number of times, you know, let's kind of come up with a special T-shirt, or if you're a mentor in the bee yard,
mhm,
a mentor's T-shirt that
Yeah.
we can give away.
mhm.
But
Yep.
we got a lot of opportunities coming to hit. Everybody's
Mhm.
been locked in for so long. They're excited to be out there.
That's for sure. Yep, that's for sure.
Hey, Jeannie, this is Greg. Can you
Yeah.
hear me?
Yep.
My internet went out halfway through the man's presentation, and I got back in the very end when he was talking right at the end. Is there
Yeah.
any way you could put his presentation with slides on the internet. So
Yes, yes.
Okay.
I just actually posted the last 4 meetings on our YouTube channel, Fairfield County Beekeepers Association. And I will be able to do this one quickly because I was having trouble with the program that Jamie Walters from OSBA was teaching us. They came out with an update, and you were supposed to uninstall the old one and install the new one. Well, the new one crashed every time I tried to use it, and so I kept sending in trouble tickets, and they finally must have fixed it because I went back on and it's now functioning. So that was the holdup. But yeah, now that I know what to do, I can do it in 10 minutes. I just need to cut the beginning and the end out. The beginning where I start the meeting and I haven't looked in the mirror all day and I see myself on the screen and I go, oh my God, my hair is a mess. And, I got a mark on my cheek from a pen and, and I'm making faces. So that's got to get cut out before it gets posted. So
that's okay.
Yeah, it'll be up.
I missed.
Yeah. It'll be up.
Okay.
Yep.
I appreciate that. I'm sitting here and all of a sudden it just says connecting and I'm looking and my internet was not working. So
yeah. And a lot of
I would.
Yep. It'll be up. We're leaving on vacation tomorrow to Oregon, but I will probably have some downtime when we're out there. So it'll be up in a week or 2.
Yeah, but we're at the mercy of the
That would be
speaker.
great.
They
Thank
gotta
you.
give us permission.
Right.
The
Right.
speaker has to give us permission.
Yep. So, all righty.
But so far they are coming around, aren't they?
Yes, they are. Yep. Yeah, they are.
So if you can't make it home in time to attend the meeting, you can see the recording.
Mm-hmm. Anybody else have questions or issues or questions about your bee yard or your hives or anything? No? All righty. Well, thanks for coming tonight, everybody. It's nice to see some of your faces, and I guess we have we have incognito guests tonight too. We didn't see Kevin Paulus tonight, but Kevin sometimes comes with a costume on, so that's always fun. Hello there. So we'll have a good evening, and I hope y'all can keep your bees and not lose them and not have them swarm on you. And remember, the bee yard is Thursday night at 6. And we'll see you in June in person.
All
So
right.
hope
Rising Park.
at Rising Park in the back shelter house. And I know there's some picnic tables, but if you want to socially distance, you can bring a lawn chair and whatever. So, all righty. All righty.
Thank you.
Well, good night, everybody. Good night, John Boy and Mary Ellen, and everybody else that's here. Thanks for coming, everybody. Good night.